This lesson is on section 10.5, using trigonometry and the area formulas. In our last sections, we've talked about area formulas for the different shapes. We talked about having to use the special right triangle ratios to find missing values. Today we're going to talk about using trig functions to find missing values in order to find the area of our shapes. It's all based on the measure of the central angles. I showed you a hexagon the other day that said that these angles down here were special and they created 30, 60, 90 triangles. Well, the central angles, if you remember, we've talked about central angles before. Central angles are the angle that go from the center of the figure. And all you do is take 360 divided by how many there are. Since the shape goes all the way around, it creates 360 degrees, so you divide 360 by how many there are, and that gives you the central angle measure. These are all for regular polygons. They do not work if your polygon is not regular, which means they all have to have the same length sides and all have to have the same interior angle measures. So we would take 360 divided by 3 in this case, and an equilateral triangle will have a central angle of 120. A square, take 360 divided by 4, and each central angle would be 90. In a pentagon, you'd take 360 divided by 5, and each central angle would be 72. And in a hexagon, you'd take 360 divided by 6, and each central angle would be 60 degrees. That's going to be helpful when we find the area of our polygons, because when we go and put in the apothem is going to divide those angles into two equal parts. So in the case of a hexagon, we already know that this creates a 30, 60, 90 triangle, but we can move the apothem into each one. So in a pentagon, this angle would measure 36 degrees. It's not a special right triangle, but it is enough to give us for a trig ratio. So we can use 36 degrees and we can use sine, cosine, and tangent to find missing values. Same thing here. In a square, it gives us a 45, 45, 90, so that's a special right triangle. And in an equilateral triangle, this would be 60, so it would create a 30, 60, 90 triangle. Some example problems. If I want you to find the area of a regular decagon, so decagon means it has 10 sides and each side has a length of 12 centimeters. Okay? The formula for the area of a regular polygon is 1/2 AP. We learned that in the last lesson. So that means we're going to have to take 1/2 times the length of our apothem, which we don't know yet, times the perimeter of the shape, and 12 times 10 is 120. In order to find this apothem length, you're going to have to use trig functions. You're going to have to use the central angle measure. Central angle measure in a 10-sided figure, I'd take 360 divided by 10, which gives me that this entire angle here is 36, which means half of it is going to be 18. If the apothem is what I'm looking for, I know that this whole side is 12, so I know that this half is 6. So I can use one of the trig functions. I can use the measure of my angle, which is 18, my side length, which is 6, and the apothem is what I'm trying to find. So I'm going to deal with the opposite and the adjacent, so that tells me I'm going to use tangent. So I would take the tangent of 18 equals 6 over a, or x, and when the x is on the bottom, they switch. So 6 divided by the tangent of 18 gives me 18.5. Then I know that my apothem is 18.5, so I can stick that into my formula, and I would take 1/2 times 18.5 times 120, which would give me an area of 1,110 square centimeters. Trying another one of these, the radius of a pentagonal garden is 18, so I know that this distance is 18. Now, in order to find the area, I have to know the apothem and I have to know the perimeter. Since I don't know either of those, I'm going to have to use my trig functions twice. knowing that my central angle in a pentagon is 72, I know that this piece here is 36. It's half of the 72. So I'm going to use 18 as my hypotenuse to find my apothem. To find this value, I would take the cosine of 36 equals x over 18. So I would take 18 times the cosine of 36, and that would give me my apothem is 14.6. So it's going to be 1/2 times 14.6 times the perimeter of my shape. I don't know what my side length is yet, but if I could find this value, then I would know what half of my side lengths are. So I would take the sine of 36 equals y over 18. And so I would take 18 times the sine of 36. That would give me that this side here is 10.6, which means that my entire side is 21.2. And so if I take 21.2 times 5, I get 105.8 for my perimeter. So I would take 1/2 times 14.6 times 105.8 to give me an area of 772.34 square feet. The last kind of problem that we're going to see is a triangle. Now a triangle has a different formula, remember. Area of triangle is 1/2 base times height, and which works really well when they give you the base and the height. However, if you look in this problem, they give us the base, but they do not give us the length of the height. The height would be represented by this value here. And so we can use trig functions to find the height of our triangle so that we can find the area. We know that our area would be 1/2 times 26 times whatever this value is. We don't know what h is, but we can use trig functions to find out. From 37, h is opposite and 14 is hypotenuse. Opposite and hypotenuse tell me to use sine. So the sine of 37 would equal h over 14. So I'd take 14 times the sine of 37, and that would give me I don't know what that would give me. 14 times the sine of 37. I just ended up putting it right in the formula, and that seemed to be easier. If you want to know what it is, you should have gotten 8.4 there. So you would take 1/2 times 26 times 8.4, and that would give you 109.5. There's actually a separate formula that you can use. If you notice what we did, we took 1/2 times the base times the other side times the sine of the included angle. There's actually a separate formula that you can use if this is what they give you if this is what they give you and they want you to find the area of it, there's actually a separate formula. You don't have to use 1/2 base times height. You can use 1/2 times the side 1 times the side 2 times the sine of the angle in between them. And that will give you the area of the triangle, just like 1/2 base times height will, except you can do it in one step instead of just two. So you'd go right to this step right here, and you could skip over the rest of this. It's just a shortcut. You're certainly welcome to use the 1/2 base times height if that's what you would like to do. And a second example using that formula specifically, since I give you two sides in the included angle, but I don't give you the height, that's the hint there that if I don't give you the height, this is a better one to use. I would do 1/2 times 11 times 6 times the sine of 83. And when I would get the area of 32.8 square inches. This is not a necessary formula. This is simply a formula that will make this problem easier. Your homework is as follows. This concludes this lesson.